the today's session. It's another fine day which God has allowed us to be together, and we appreciate Him for that. So I want us very straight. We go now to a very important topic, which is examination language, which we usually use when we are examining students. And I want very fast, we start with the name. When you are told to name, it must be a UPAC name. For example, if you are told the gas to be produced is carbon 4 oxide, don't say carbon dioxide, say carbon 4 oxide. And please, if you are told to write the formula, if you are told to name, don't write the formula. If you give the formula together with the name, then the formula must be correct. Any, you'll be penalized. Secondly, I request you, if you have got any question, you can just ask as we continue, because it will be very good, because you might tend to forget when you're asking. Now, when you're taught to identify, when you're taught to identify, you can give either the name or the formula. But if it's important you write the two, then both of them must be correct. For example, you can be given a diagram. You are told to identify gas M. If that gas M is hydrogen gas, you can either give H2, which is the hydrogen gas, or you can give the name, which is just hydrogen gas. Thirdly, you'll be told to state. If you are told to state one, you can be told to state the use. If you are told to state the use, it must be commercial use. For example, state 2 uses of oxygen. Don't say oxygen is used in respiration. That is not a commercial use. You can say oxygen is used in removing impurities in steel making. Remove impurities from iron during steel making. Secondly, you can also be told to state the observation. When you are told to state the observation, you must talk about the original color to the final color, failure to which you will be penalized. For example, if you are passing hydrogen gas through copper 2 oxide, then you must say the black copper 2 oxide changes to a brown substance or a red solid. Don't say red brown, just talk about one color. In your book for chemistry for paper 1, form 1, they talk about red brown. I'm a reddish brown. Talk about red solid or brown solid. Again, if there is formation of a colorless liquid, droplets, don't say a liquid condenses. Liquid can never condense. It's the vapor which condenses, or a colorless vapor condenses to form a colorless liquid. Mark it clearly. It should be the vapor condensing. It undergoes condensation so that it can be turned back to the liquid state. Thirdly, you can be told to state the law. For example, state Boyle's law. You state at constant temperature and pressure, at constant temperature, the volume of a fixed mass of a gas is inversely proportional to its pressure. Here you can see the condition. The condition there is about the constant temperature. So it must be very clear. Again, you can also be told, state Gay-Lussac's law. You are told to state, you must state clear the condition. When gases react, they do so in all number ratios to one another and to the volume of products, if gaseous, at constant, mark, at constant temperature and pressure. Thirdly, fourthly, you can be taught to explain. Explain the trend. It can either be ionization energy. For example, the ionization energy, it decreases down group 1, still down group 2, because of the increase in atomic radius or atomic size. So in that case, show the comparative aspect and the reason. Still, you can be told, explain in terms of structure and bonding. For example, explain why magnesium chloride has a very high melting point and boiling point than phosphorus 3 chloride. So in that case, you need to show which kind of structure and what type of bond. For example, magnesium chloride has a giant ionic structure. Ions held together by strong ionic bond. So you are very categorical. There is a structure and the type of bond. While phosphorus 3 chloride is a simple molecular structure. Molecules held together by weak van der Waals forces. So you can see you are very specific to the structure and still the type of bond which is present in that compound. Still, you can be told, explain observation. For example, what happens when hydrogen gas is passed through copper 2 oxide? One, you don't need to repeat the same observation. Let's say hydrogen reduces copper 2 oxide to copper metal and itself is oxidized to water or hydrogen oxide. Mark, you are not repeating the same observation. You are giving the explanation for the observation. Next, you can be told to describe. In describing, you must indicate the apparatus which you are using. For example, describe how you can obtain oil from groundnuts. In that case, you need to place a few groundnuts in a motor. So the apparatus here, we have a motor. There's using a pencil, crush. So you can see, you are using the apparatus there. Then as you continue crushing, you add propanol or ethanol. Mark, you add ethanol or propanol. Then decant the resulting solution. Place the resultant solution in the sun for the solvent to evaporate. Then the remains will be now the oils. If you want them to be pure, then you add water and separate using separating funnel. So in describing, all steps must be clear. All steps are must. Marking stops where the sequence goes wrong. And again, where there is volume and molarity are present, show the concept of mole ratio. For example, using 100 centimeters cubed of 2 molar potassium hydroxide, using 100 or 200 centimeters cubed of 2 molar sodium hydroxide, describe how sodium or potassium sulfate can be prepared. So in that case, you need to show the mole ratio between the reaction between the sodium hydroxide and sulfuric 6 acid. The mole ratio is always 1 to 2. So always show the mole ratio. Next, and please, I'm waiting questions if you haven't got any question, you can show it out or you can text. Another term which you use is distinguish. For example, distinguish between isotopes and allotropes. In that case, you should show the difference between the two. For example, isotopes are atoms of the same elements with the same atomic number but different mass number. Same atomic number but different mass number. While the difference there, while allotropes, they are different crystalline, different crystalline forms of an element in the same physical state. The term crystalline form must be present. If not so, you'll be wrong. Different crystalline form of an element in the same physical state. Differentiate also atomic number and mass number. Can also be given that. So mass number is the sum of the protons and neutrons in the nucleus of an atom of an element, while atomic number is the number of protons in the nucleus of an atom of an element. Next, another term which you can use, or which you can be given, we have equations. When you are taught to write an equation, one equation is correct and complete if it's balanced and as state simple. If it has no state simple, then you will be awarded a half a mark. That will be in a complete equation. While in a correct equation, you are awarded 0 mark. For example, you can be told, write the equation between potassium and copper 2 oxide. There will be a displacement there, and the condition there must be heat, which will be the activation energy. So in that case, you need to be very clear. Stay simple, clear, balancing also correct. Next, you should, there are elements which you must mark the state simple. They are state simple. For example, we have potassium. Some students write potassium as like that, 1 and a C, to mean that it will be K. This would be incorrect. So we check very clear. It should be capital letter K, like that. So be very clear. Secondly, you can be told to write copper. Chemical symbol for copper, we have capital letter C and small letter U. Show that U, that tail, that loop. Show it. Again, we have chlorine. Write it as C and small letter I, capital letter I. Don't write it with a loop like this one. This will be incorrect, but this will be correct there. Next, we have silicon. Some students try to write as capital letter S, then I. That I without a dot there, then it will be a capital letter I. So the dot must be present there. Next, we have lead. If you write like that, this will be small letter p. That would be incorrect. So the chemical symbol for this should be letter P, show that P, then small letter B, like that. This would be correct. Again, we have iron, capital letter F. Some student write this would be incorrect, or like this will still be incorrect. Should be capital letter F, small letter I. Those are the very important symbols which you should check and which you can make you fail. In Kcse 2015, paper 2, they asked 7 different questions which involves writing the chemical symbol for chlorine and the chemical symbol for aluminium. So for aluminium, it should be very clear, like that. Don't place with a loop. Don't place with a loop like that. So be very clear to what you are writing. Next. Next. We have formula for organic compounds. When you are told, for example, write the structural formula of pentane, structural formula for pentane, the bonds must be correctly directed. Also for ethanol, we have the structural formula for ethanol. First, write the molecular formula, which is C2H5OH. When you are told open structural formula, open all the bonds. Like in this case, you now have C attached to C, attached to O, which is also attached to hydrogen. Open that bond. This will now be attached to hydrogen, attached still to hydrogen, hydrogen again, hydrogen here, hydrogen there. You are very clear. Open structural formula. If at any case you don't open this, for example, C, OH, then it's clear. Open structural formula, and you have not opened this, then it will be incorrect. You must open all the bonds. Clear? Next. And again, it comes where now you are told draw isomers. Isomers, for example, in 2016, question 5, you are told draw the isomers of pentane. Isomers of pentane. First, show the molecular formula of pentane. C5H12. Draw the straight chain. C attached to C, attached to C, another C, and another C. The rest will be hydrogen. Hydrogen here. All these are hydrogen. You correctly direct the bond like that. Like that. Secondly, remove this carbon 1, take it to carbon 3. Don't take it to carbon 2 because it will be still the straight, it will be the part of straight chain. So place it there to be like this now. CH3. You have placed it to carbon 3 like that. Now the name hydrogen. All these hydrogen, each carbon atom should have 4 bonds. So all that, this is another state. You can also place this last carbon, you place it to carbon 2 again, that carbon 2. So in that case, it will be this kind of structure. CH3, CH3. This will be CH3, then this will be 2. So this carbon here to be tertiary carbon. So the name to be 2,2. The name will be 2, 2 dimethyl. They are 2. So you must show they are how many they are. Dimethyl propane. Saturated carbon. To mean that each carbon atom is attached to a single covalent bond. That's why we say it's saturated. Alkanes are saturated hydrocarbons. Next, complete Odra diagram. In that, the workability of the diagram is checked. For example, you are provided with a trough, sodium hydroxide solution, gas jar, burning candle. Draw the experiment to show how you can determine the percentage of oxygen in the air. So in that case, you can be told at the end of the experiment. So you must show that the candle went off and the volume of the sodium hydroxide increased. For example, now in your diagram, this will be a trough. So you show the volume of, first you show that will be the gas jar. Then we have that volume of sodium hydroxide. Then it increased in the gas jar. Then here we have a candle which is up there, and it went off like that. So then from there, label. Don't fail to label. Trough, sodium hydroxide solution, candle, gas jar, like that. That question was there in 2017. Next, in calculation. When you are calculating, first, for example, where there is an equation, equation is a must indicate the equation. Then rounding off is always penalized. If you want to round off, use 2, 3, 4 rule, where volume must be into 2 decimal places, molarity a minimum of 3 decimal places, and moles a minimum of 4 decimal places. Always avoid as much as possible rounding off. The calculations involving relative atomic mass, that is RAM, relative formula mass, RFM, or relative molecular mass. No units required. That means it should have no units because it's a ratio. Relative means you have already compared. So no units will at any given time be required in those calculations of RAM, RFM, and RMM, relative molecular mass. Any other calculations, units are must. And whether you are not sure of the units, leave it without units. The examiner there will award you again molarity. You abbreviate it as capital letter M, no small letter m. Seconds should be small letter m and not capital letter S. Seconds, capital small letter S, not capital letter S. Where there is the expression of energy, should be kilojoules per mole. K is a small letter. J is the unit, which is supposed to be a capital letter J. Per mole, the mole there is small letters. M, O, L, small letters. Not capital letter K, small letter J, capital letter J, and small capital letter M, O, L. That will be penalized. Units are penalized a half a mark at the final answer. Then lastly, when you are told to show on the diagram, it must be clearly on the diagram, not anywhere else. Clearly on the diagram. For example, you are given the electrolysis of aluminum oxide, molten aluminum oxide. So in that case, we have that one. Then we have the battery here. Then you are told, show the anode. So check the diagram. The anode is the one with the big arrow here. So in that case, show the one which is inside, not here. This will not be anode. The anode will be the one which is attached or which is in contact with the electrolyte. So this will be the anode. It's in contact with the electrolyte. If you indicate here, then you'll be wrong because it's not in contact with the electrolyte. Here, you are not in contact with the electrolyte. So that will not be the anode. The anode should always be in contact with the electrolyte, which now is that one. Clear? Any question up to that far? No, sorry. Any questions so far? Any questions so far? Good. Now, areas of emphasis. We have the industrial processes. And the industry of processes, industrial processes, one, we check the Form 1 process, which will be the fractional distillation of liquefied air. Fractional distillation of liquefied air. That is in Form 1. 2, we have the survey process in Form 2. Survey process. 3, we have the manufacture of ammonia, which we call it harbor process. Harbor process. 4, we have industrial manufacture of nitric 5 acid. Nitric 5 acid, which we call it ostward process. Ostward process. 5th, we have the French process, that is the extraction of sulfur. Next, we have the manufacture of sulfuric 6 acid. Manufacture of sulfuric 6 acid, which you call it contact process. Next, we have the manufacture of hydrogen chloride, which is HCl. What you should emphasize on this, 1, check on the raw materials. Secondly, the sources of these raw materials. Sources of raw materials. For example, in the manufacture of ammonia, the raw materials here, we have nitrogen, which is a gas, and we have hydrogen, which is a gas. The sources of these raw materials, for example, nitrogen gas, this is from the air, that is through fractional distillation of liquefied air. Then the source for hydrogen gas, we have natural air. We still have electrolysis of brine. Electrolysis of brine. Again, cracking of alkanes. Then we have different types of cracking. We have the catalytic, we have thermal, and still the one which is not discussed in Form 3 book, which is steam cracking. So raw materials and their sources. Secondly, the equations involved. Thirdly, the steps. And fourthly, the mechanism, the reaction mechanism, that we can join together with the equations. Reaction mechanism. mechanism. Next, in paper 1, always there must be a law. So you need to remember all the laws which you have learned. Is that in form 2? In form 3, we have gas laws. We have Boyle's law. Boyle's law. We have Charles' law. Charles' law. We have Avogadro's law, which says equal volumes of gases have contains equal number of molecules. Still have Gay-Lussac's law. Lussac's law. We have the Kcse law. Kcse law. We have still the Cartesian principle. And we have Faraday's law. Faraday's law. Still on those laws, look on mathematical or numerical applications. Numerical applications of these laws. For example, the combined gas equation, which we call it the ideal gas equation. Ideal gas equation, which now is P1 V1 out of T1 is always equal to P2 V2 out of T2. This is very clear. Every time the temperature should be absolute temperature. Absolute temperature. When you're told to state Charles' law, it states that the volume of a fixed mass of gas is directly proportional to its or to absolute temperature. Don't leave the term absolute. If you leave, you'll be wrong. So it's directly proportional to absolute temperature at constant pressure. The term absolute, very necessary. Next, another area we should emphasize, gas preparation. Gas preparation. Like in form 1, you prepared oxygen gas. You used 3 different methods. We have heating of potassium manganate 7. Potassium manganate 7. Heat, adding water to sodium peroxide. Add water to sodium peroxide. Sodium peroxide. And lastly, catalytic decomposition of hydrogen peroxide. Those are the 3 methods of preparing oxygen. That's in form 1. Another gas which is also prepared in form 1 is hydrogen gas. And here, you looked on the preparation of that hydrogen gas by use of reaction of metal and acid. As to be specific, you reacted with zinc, which is solid. You reacted with HCl, which is aqueous, and this produced zinc chloride and hydrogen gas. Always I've said you are writing equation, it must be balanced for it to be correct, and it must have state symbols for it to be complete. Then in form 2, you prepare the carbon 4 oxide and still carbon 2 oxide. In form 3, you prepared ammonia gas. You also prepared nitrogen gas, nitrogen 1 oxide, nitrogen 2 oxide, nitrogen 4 oxide. Then you went ahead, you prepared nitric 5 oxide fumes. And here the apparatus which you use retort flask. Not another flask, retort flask, because this nitric 5 acid gas is a very strong oxidizing agent. Very strong oxidizing agent. You went ahead again, you prepared hydrogen chloride gas. And this hydrogen chloride gas, you also prepared hydrochloric acid by dissolving the hydrogen chloride gas in water. So when you dissolve hydrogen chloride, which is a gas, you dissolve in water, dissolving that gas in water. This is not a chemical reaction. So you get hydrogen chloride, which will be an aqueous. So you indicate in the arrow the water because you are just dissolving. It's not a chemical reaction. It's not a chemical reaction. So those are the gases which you prepare in the form 4, in 844 level of, in the form 4 level, up to form 4 level. Then another area which you should also emphasize is on organic chemistry. Organic chemistry. And here, look on the naming, which is nomenclature. Nomenclature. The isomers or isomerism. Isomerism is the existence of a compound in the same molecular formula but different structural formula. Those different compounds, they are known as isomers. Next, look on the addition reactions of alkenes and alkynes. Addition reactions. Addition reactions of alkenes and alkanes. And here, specifically, we have hydrogenation. Hydrogenation. That is addition of hydrogen. We still have halogenation. That is an addition of halogen to either alkene or alkyne. Then we have addition of halo. Hydrohalogenation. Hydrohalogenation. That is the hydrogen halides. Hydrogen halides. For example, hydrogen chloride. That is an addition of hydrogen and chlorine. So in this case is hydrogen halide. Hydrogen bromide. Still an example of hydrogen halide. Then we have addition of an oxidizing agent. And the oxidizing agent should be acidified. For example, acidified potassium manganese ion. That should be acidified. When you add it to ethene, you add it to ethene, you adding this substance there. So what you get there, it is an alcohol, which you commonly refer to as glycol. C, correctly direct the bond, or H. This bond here, the covalent bonds attached to carbon, to oxygen, still OH. This is what we commonly refer to it to as glycol. The chemical name for this, the IUPAC name for this, is ethane 1,2-diol. Ethane 1,2-diol. Next, we have addition of concentrated sulfuric 6 acid. Considering this, which is ethene, when you add it to sulfuric 6 acid, you get ethyl hydrogen sulfate. You get to ethyl hydrogen sulfate. Next, you can hydrolyze ethyl hydrogen sulfate. Hydrolyze ethyl hydrogen sulfate, this formula here. This, of course, is the ethyl hydrogen sulfate. You hydrolyze means you are adding water. Hydrolysis means, lysis itself means breaking. Hydrolysis, breaking using water. So you are breaking using water here. To remove this, here, what adds itself is OH. So you get an ethanol plus dilute sulfuric 6 acid. Next, we have the self-addition process or mechanism, which we call it polymerization. Polymerization. Conditions for polymerization, we have high temperature and pressure. High temperature and pressure. Those are the conditions. Talk about a temperature, high temperature is above like 450 degrees Celsius. That's why these are low temperature. But practically it's very high. Then the pressure above 200 atmospheres. But those are the reactions. Then again, you also look on detergents. The cleansing action of soaps and soapless detergents. From detergents, You should also emphasize or look on the polymers. Emphasize on condensation, polymerization. For example, the synthesis of nylon 6,6. Nylon 6,6. The reagents for production of this or for synthesis of nylon 6,6. Then also on addition reactions, addition polymerizations. We emphasize on the double bond and triple, double or triple bonds. Up to that point, any question? You can post any question. Some of questions which you can come across. Describe how lead 2 chloride can be prepared. Lead 2 chloride can be prepared. First, any method of preparing a salt depends on the solubility of that salt in water. So you need to remember the 4 rules of solubility of salts. The first, all nitrates are soluble, all sulfates are soluble, except calcium sulfate, which is partially soluble. Lead 2 sulfate and barium sulfate. Those are the only sulfates which are insoluble. Thirdly, all chlorides are soluble except silver chloride and lead 2 chloride, which is soluble in warm water. Then lastly, all carbonates are insoluble except carbonates of group 1 and ammonia. Ammonia always exhibits characteristics of group 1 elements, ammonium ion. So the moment you notice that this is an insoluble salt, the only method which you can use to prepare it is double decomposition. And in double decomposition, it involves precipitation reaction. Precipitation reaction. And double decompositions, it involves mixing 2 soluble salts to obtain 1 soluble and another insoluble. For example, lead 2 chloride is insoluble. So first prepare a soluble lead salt, and specifically lead 2 nitrate. Lead 2 nitrate is soluble. You react it or you combine it with a very soluble chloride. For example, sodium chloride. This will be aqueous. Still, this is aqueous. And this will obtain lead 2 chloride, which is solid, and sodium nitrate. Always balance that equation, 2 here and 2 there. When you are writing any equation on a single line and you find it cannot fit on that line, don't write the product as if they are in the reactant side. Always there is an imaginary line which must be separating the reactants from the product. So here, you need to know which salt you are preparing. And as you remember, I said where there is volume and molarity, involve the concept of mole ratio. For example, you are preparing sodium sulfate from a mixture, from a reaction of 200 centimeters cubed of 0.5 molar sodium hydroxide, and you want to prepare sodium sulfate. So the moment you want to prepare this, here you can use any reaction, but here you are going to specifically use a reaction between a base, which you are given, and an acid. So the acid which you are going to use is sulfuric 6 acid, which will be active. So in that reaction, you need to understand the concept of mole ratio between the sodium hydroxide and sulfuric 6 acid. And you have to recognize very fast that the mole ratio of sodium hydroxide to sulfuric 6 acid is 2:1. So you need to have any. Here you are using 200 centimeters cubed of 0.5 molar sodium hydroxide. So in that case, you can have the volume, or you can have the molarity. So you can say, to the solution of sodium hydroxide, add 100 centimeters cubed of 0.5 molar sulfuric 6 acid. That there will be complete neutralization. Then heat the solution to saturation. Allow the saturated solution to cool to form crystals. Then dry the crystals between filter papers. Clear? Another question? Any question?